We start off with a parabola that is not in standard form, and our first job is to put that equation in standard form so that using it we can find all these other things down here, the vertex, the focus, and so on. So the way you put this in standard form first, I would suggest figuring out whether this parabola opens up, down, left, right. Okay, is it vertical or is it horizontal? Now here's what vertical parabolas look like. You should recognize y equals x squared. That's an old school thing we've been talking about for years. That's a parabola that opens up. And if you had a different equation, like y squared equals x, that's a parabola that opens sideways. So we're going to take those two ideas, and notice this is a y squared. So that tells me right now I am dealing with a horizontal parabola of some kind. It's a little more complicated than the one I have on the right. Okay, so horizontal parabola. And my first task is, remember where we're going with this. I should back up. I want it to look something like this. Y minus k squared equals some number times x minus h. Okay, that's my standard form for a horizontal parabola. Well, the easiest way to get it there is to put all my y's on the left side and my x's on the right. So let's do that. I'm going to say y squared plus 4y equals, and then I bring everything else to the right side. It's going to be negative 4x minus 20, I think, right? So negative 4x minus 20. And to finish out this left side, that's my focus right now, I need to get it to be a perfect square. And the way you do that is by taking the linear term, cut it in half, and square it. Okay, we've talked about this a bunch in class. You cut 4 in half, you get 2, you square it, you get 4. Now you have to add that to both sides. Look where this gets us. If I factor this, I've got y plus 2 squared. On the right side, this becomes negative 4x minus 16. Okay, so that becomes, if I factor out the negative 4, I've got x plus 4. And of course, the left side, that was completed in the last step, so I can just rewrite this. And now I have standard form. So this guy right here, let's grab this equation, and that is what I want. That's my standard form parabola. So if you look at that and you ask, well, what is the vertex from this thing? Remember what the vertex is. Vertex is h comma k. So h, according to this equation right over here, is going to be negative 4. And k, according to this side right here, is going to be negative 2. Okay, so that's a start. And the next thing I want is my focus. And this is where things get a little more complicated than just reading the equation. The focus, if you remember what a parabola looks like, especially a horizontal one, let's draw my vertex on here. Vertex negative 4, negative 2. Okay, so that's like right here. There's the vertex. Well, which way is this thing opening? Is it opening to the left or is it opening to the right? I mixed up my left and rights, but you get the idea. I want to know which way it's facing. And the way you do that is by figuring out what P is. So we're going to skip down to this step right here. Now, that is the absolute value of P. This is the absolute value for P. Okay, so we're going to fill those in. But P is what I'm focusing on right now. P is equal to negative 1, according to that standard form equation. That's the other really important part of this. So, can't catch a break with my eraser here. There we go. So if P is negative 1, that means this thing is opening to the left. Okay, it's going to look something like that. And I can fill in my focal length. That's just the absolute value of negative 1. I can fill in my focal diameter. That's 4. But we still haven't talked about the focus yet. Well, where is the focus going to be if my parabola is opening to the left? It's going to be in here somewhere. The parabola has to wrap around the focus. Okay, so you've got your vertex, and that's the turning points of the parabola. And you've got your focus, which the parabola seems to wrap around. The distance between the vertex and the focus, this little guy right here that I'm shading in super dark, that distance is the focal length. So you can see why I drew the focus 1 unit to the left of the vertex, because P is negative and its magnitude is 1. So I'm going to say the focus is located at negative 5, comma negative 2. Okay, great. So that's a really good start. Let's get rid of this sketch parabola. We're going to do better than that. The focal diameter is 4. Oop, not ready for that yet. I want the equation of the axis of symmetry. Well, the axis of symmetry is easy. You just find the focus and the vertex, draw a line connecting them, and that line is your axis of symmetry. And if you think about the shape of your parabola, remember it looks something like this? This is the line about which the parabola is symmetric. So what is that equation? That's going to be, let's see, it's a horizontal line, so that's y equals, and the y value of the vertex is -2. Okay, so -2. There we go. And now we're just about ready to draw this thing. I've got one more thing to iron out, the equation of the directrix. If you remember what the directrix is, that is a line perpendicular to the axis of symmetry, so it's a vertical line, and it's going to go like this. The reason I'm drawing it right here is because this has to be the same distance between the vertex and the directrix that you have between the vertex and the focus. It's another focal length away. So that vertical line where I drew it right there is going to be x equals, and we look at the x-coordinate, that's -3. Okay? So what do we have left here? Just need to draw this thing at this point. We're doing pretty well. I'm going to clean up this graph a little bit. There we go. Now, I need to plot the focus. Done. I don't need to plot the vertex, but I like it being on there. It's helpful. Directrix we've got looking like this. And the lattice rectum. Remember what the lattice rectum is. That is a line parallel to the directrix, which has a focal diameter as its length, and it's centered on the focus. So it cuts through the focus. It's got a length of 4 units. See what I just drew here? That is a 4-unit long segment, and that defines how wide the parabola is. If you've got a huge lattice rectum, that's going to be a huge parabola. So let's just draw this thing like so. Okay, it's going to hit the end points of the lattice rectum like that, and there we go. That's our expertly drawn horizontal parabola. It's opening to the left, again, because p is negative. It's horizontal, again, because y squared, and that's that.